Imagine a world without measurements. We couldn't build houses, bake cakes, or even tell time. Measurements are fundamental to our understanding of the universe. They allow us to quantify the world around us, from the smallest atom to the largest galaxy. In science and engineering, accurate measurements are crucial. They form the bedrock of experiments, design, and innovation. Without precise measurements, scientific discoveries would be impossible, and engineering marvels would remain dreams. From the simple act of measuring the length of a table to the complex task of determining the distance to a star, measurements are the language of science. They allow us to communicate our observations and theories with precision and clarity. The tools we use for these tasks, measuring instruments, are our eyes into the hidden workings of the universe. They extend our senses, allowing us to perceive phenomena beyond our normal perception. Let's delve into the fascinating world of measuring instruments, where precision and accuracy are paramount in various fields such as engineering, science, and everyday applications. We will uncover the principles that govern their operation and understand how they help us quantify the physical world around us. One common type is the Permanent Magnet Moving Coil, or PMMC instrument, which is widely used due to its reliability and precision. In a PMMC instrument, a coil of wire is suspended within a magnetic field created by a permanent magnet. This setup is crucial for its operation. When an electric current flows through the coil, it experiences a torque due to the interaction with the magnetic field, causing it to rotate. This rotation is a direct response to the current. The amount of rotation is proportional to the current, allowing us to measure it accurately. This proportionality is what makes PMMC instruments so effective for precise measurements. Another widely used instrument is the Electrodynamometer, which is known for its ability to measure both direct and alternating currents. Unlike the PMMC, it doesn't rely on a permanent magnet. Instead, it uses a different mechanism to achieve its measurements. It utilizes two coils, a fixed coil and a moving coil. The interaction between these coils is key to its operation. When current passes through both coils, they generate interacting magnetic fields, causing the moving coil to deflect. This deflection is a measure of the current. This deflection, again, is proportional to the current being measured, ensuring accurate readings for both AC and DC currents. Rectifier-type instruments are used for measuring alternating current, or AC, which is common in household and industrial applications. They work by converting AC to direct current, or DC, using diodes. This conversion is essential for accurate measurement. The resulting DC is then measured using a PMMC instrument, leveraging its precision to provide accurate readings of the converted current. Finally, we have the Digital Multimeter, or DMM, a versatile tool that has become indispensable in modern electrical and electronic work. A DMM is capable of measuring various electrical quantities like voltage, current, and resistance, making it a multifunctional device for professionals and hobbyists alike. DMMs utilize sophisticated electronic circuits to provide accurate and digital readings, ensuring reliability and ease of use in a wide range of applications. Measuring instruments come in two primary flavors, analog and digital. Analog instruments like the PMMC display measurements using a pointer moving over a calibrated scale. They are simple, intuitive, and often preferred for visualizing trends. Digital instruments, on the other hand, present measurements in numerical form on a digital display. DMMs are a prime example. They offer high accuracy, resolution, and the convenience of direct digital readings. However, each type has its trade-offs. Analog instruments may suffer from parallax error, which are reading inaccuracies due to viewing angle and limited resolution. Digital instruments, while precise, can sometimes mask transient signals or fluctuations. The choice between analog and digital depends on the specific application and desired accuracy level. For quick visual checks or trend analysis, analog instruments might suffice. For precise measurements, digital instruments are the preferred choice. Section 4. Measuring performance, accuracy, and beyond. Just like a telescope's clarity determines the sharpness of distant stars, a measuring instrument's performance dictates the reliability of our measurements. Two key aspects are accuracy and precision. Accuracy refers to how close a measurement is to the true value. Think of it as hitting the bullseye on a target. The closer your arrow lands to the center, the more accurate your aim. Precision, however, relates to the repeatability of measurements. Imagine shooting several arrows. If they all cluster tightly together, you have high precision, even if they are off-center. In addition to accuracy and precision, other factors like sensitivity, resolution, and error contribute to an instrument's overall performance. Understanding these factors is crucial for selecting the right tool for the job and interpreting measurements correctly. Just as a blurry telescope limits our view of the cosmos, an imprecise instrument hinders our understanding of the physical world. Section 5. Instruments in action, from labs to daily life. Measuring instruments are ubiquitous, silently shaping our world from behind the scenes. They are the unsung heroes, working tirelessly to ensure that the data we rely on is accurate and reliable. In research labs, they empower scientists to unravel the mysteries of the universe. These instruments are the backbone of scientific discovery, enabling researchers to conduct experiments with precision and uncover new knowledge. The Cathode Ray Oscilloscope, or CRO, allows us to visualize electrical signals, revealing the hidden patterns of electricity. By displaying these signals, the CRO helps scientists and engineers understand the behavior of electrical circuits and systems. Its digital counterpart, the Digital Storage Oscilloscope, or DSO, further enhances our capabilities, offering storage, analysis, and measurement features. The DSO can capture and store complex waveforms, making it easier to analyze and interpret data. Signal generators are another indispensable tool. They produce various electrical waveforms, acting as the heartbeat of countless electronic circuits and systems. These waveforms enable engineers to test and analyze their creations, ensuring that their designs function as intended. Without signal generators, the development and testing of electronic devices would be significantly hindered. But the impact of measuring instruments extends far beyond laboratories. They play a crucial role in various industries, from healthcare to manufacturing, ensuring that processes run smoothly and products meet quality standards. In hospitals, they monitor vital signs, ensuring patient well-being. Medical instruments such as heart rate monitors, blood pressure cuffs, and thermometers provide critical data that doctors and nurses use to make informed decisions about patient care. In factories, they control processes, guaranteeing product quality. Measuring instruments like calipers, micrometers, and gauges are essential for quality control, ensuring that products meet specifications and are free from defects. And in our homes, they manifest as thermometers, weighing scales, and even the humble clock on the wall. These everyday tools help us manage our daily lives, from cooking and baking to keeping track of time and monitoring our health. From the mundane to the extraordinary, measuring instruments are the silent sentinels of the modern world, ensuring accuracy, precision, and progress in every sphere of life. They are the foundation upon which our technological advancements and daily conveniences are built, quietly working to make our world a better place. At Section 6, Beyond the Basics, a universe of exploration. We've only scratched the surface of the vast and fascinating world of measurements and measuring instruments. These tools, often taken for granted, are the unsung heroes of countless discoveries and innovations. Our journey has taken us from the fundamental principles behind these tools to their diverse applications in science, engineering, and everyday life. Whether it's a simple ruler or a complex spectrometer, each instrument plays a crucial role in our quest for knowledge. As we delve deeper into this universe, we encounter increasingly sophisticated instruments, each designed to probe specific phenomena with greater accuracy and precision. These advancements allow us to explore realms previously beyond our reach. Each of these tools, from the most basic to the most advanced, is a testament to human ingenuity and our relentless pursuit of understanding. They enable us to quantify the world in ways that were once unimaginable. From electron microscopes that unveil the intricate details of matter, revealing structures at the atomic level, to radio telescopes that peer into the depths of the cosmos, capturing signals from distant galaxies and stars, our ability to measure continues to expand our understanding of the universe. These instruments are our eyes and ears, extending our senses far beyond their natural limits. Just as the invention of the telescope revolutionized astronomy, allowing us to see the heavens in unprecedented detail, advancements in measuring instruments continue to drive scientific breakthroughs and technological innovations. Each new tool opens up new possibilities, leading to discoveries that reshape our understanding of the world. As we develop even more sensitive and precise tools, we push the boundaries of what we can observe and measure. We can expect to unlock new secrets of the universe, uncovering phenomena that were previously hidden from view. These discoveries not only satisfy our curiosity, but also have practical applications that can improve our lives, leading to a deeper appreciation of the intricate workings of the natural world. From the smallest particles to the vastness of space, measurement is the key to understanding. The journey of exploration and discovery is endless, and at its heart lies the fundamental act of measurement. It is through measurement that we make sense of the world and our place in it. So, the next time you encounter a measuring instrument, take a moment to appreciate its role in shaping our understanding of the world around us. These tools are not just devices, they are gateways to knowledge. They allow us to quantify, analyze, and ultimately comprehend the universe we inhabit. Each measurement brings us one step closer to the truth. Take a moment to reflect on the incredible journey of discovery that these instruments enable. They are the bridge between the known and the unknown. For within these tools lies the power to quantify, analyze, and ultimately comprehend the universe we inhabit. They are the silent partners in our quest for knowledge, ever pushing the boundaries of what we can achieve.